Hello friends, welcome to the session. In this session, we'll be discussing about classification of the data structure. In our earlier session, we have discussed what we mean by data structure and why it is necessary to study the data structure. Friends, as you know, that data represent the facts, and in real life, we are always dealing with the facts. Whenever we have a data elements, then we need to organize the data elements. And organization of the data elements itself is being called as a data structure. But why should we organize the data? We should organize the data so that we can make an efficient access to the data elements. So whenever you want to become a good programmer, then for good programming, it is necessary for the programmer to have a proper selection of the data structure for its program. So in this session, we will see what are the different types of data structure available so that the programmer can make an efficient access to the data. So let us start the session. As you know that we have been recording this session for PSS Central Institute of Vocational Education for the course of Junior Software Developer. You will find that the students from other courses also can make an access to these sessions so that they can learn the data structure to become a good programmer. So let us start the session with the question, what we mean by the classification of the data structure. So data structure classification is a kind of logical and mathematical model that is being used for organization of the data. You will find that the data structure is used for organization of the data, and whenever we want to organize the data, then we need some logical model. We need some mathematical model, and such formation of the logical model and mathematical model for the organization of the data is itself is a data structure. And when we have a data structure, then we can classify it into two main categories. The first category is called as the primitive data structure, and the other category is being called as a non-primitive data structure. So let us understand what we mean by primitive data structure and non-primitive data structure. So primitive data structures are those data structures that cannot be further divided, and that is the reason they are being called as a primitive data structure. Say for example, whenever we deal with the data values such as integer number or real number or characters or boolean values, you will find that these are the data elements for which the further division is not possible. Any integer number cannot be further divided. Any real number cannot be further divided. Any character cannot be further divided, or any boolean values such as true and false cannot be further divided. And therefore these are the basic data elements, and therefore these basic data elements are being called as the primitive data elements. So as shown in this diagram, you will find that the data structure itself is being classified as the primitive and non-primitive data structures. In the primitive data structures, we have integer, real, character and boolean. And in the non-primitive data structure, there are many different types of data structures available. For example, we have a linear data structure and we have a set of non-linear data structure. In the linear data structure, we have the different elements such as arrays, linked list, stacks and queues. And in the non-linear data structure, we have the different elements such as trees and graphs. So this is the session that we have been devoting for elementary understanding of these different data structures. So as I said, we have the non-primitive data structures where we have basic two categories. The first one is called as the linear and the second one is called as the non-linear. So as its name indicates, the linear means these data elements can be arranged linearly, that is sequentially. And non-linear means the elements need not to be arranged sequentially, but they can be arranged anywhere in the memory. So you will find that in linear, again we have the two types. One is called as the static. Static means it normally does not change, and that is the reason it is being called as a static. And dynamic means it normally goes on changing, that is its size goes on changing, and therefore it is called as a dynamic. So static is a data element or data structure of which the size is fixed. Say for example, we can have an array of which the size is fixed, and therefore we call it as a static. But we have the different other linear elements such as linked list, stacks and queues, where you will find that the size is not fixed and it may change or it may differ, and that is the reason we call them as the dynamic. Sometimes we do not require the consecutive or sequential representation of the data elements, and such data elements are being called as the nonlinear data elements. For example, we can have the tree data structure or a graph data structure, which can be called as a nonlinear data structure. So let us have some elementary understanding about these different data elements that we always need to do whenever we write any real life programs. So as I said, the linear data structure is called as a linear because it forms some kind of sequence. For example, we can have an array. So array is a data structure where we can make a list of elements. Say for example, whenever I am teaching in a college, then I have some students enroll in my class. So I will prepare a list of students. So this list of students can be called as an array. We can have a linked list, or we can have stack, or we can have queues, which are also linear data structure. And when the data elements need not to be arranged in the sequence, and we can have a different sequence, then such a case we call them as the nonlinear data structure. For example, we can observe a tree as a data structure which is nonlinear, or a graph as a data structure which is nonlinear. You will find that most of the concepts that we learn in computer science are taken from the nature itself. So whenever you go to the garden and observe a tree, you will find that the same tree is being used for representation of the data. Or whenever you go on a railway station to purchase a ticket, you will find that there is a queue of persons to brought the ticket, and the same concept is being taken here also. So whenever you go to the library, you will find that there is a large collection of books, and books are arranged one after the other, and therefore we can call it as a stack of the books, isn't it? So everything, whatever we learn in computer science or whatever we learn in data structure, you will find that most of the things are taken from the real life only, and we have modeled them, we have given them some logical shape, we have prepared a mathematical model for it, and then we have implemented it in the form of a program. So let us understand what we mean by an array. Array is a linear list of elements. So we can have an array as a one-dimensional array, we can have array as a two-dimensional array, we can have an array of three-dimensional also. So whenever you have been given a certain sequence, one column or one row, then you can call it as a one-dimensional. Whenever you have been given a table of elements, then you can call it as a two-element. Whenever there is some additional attribute or variable associated, then it can be called as a three-dimensional array. So whenever we have the number of elements in the array, then every element in the array is being recognized by a value called as an index. So every element in the array is being associated with an index value. So normally the first element of the array will have the index value 0. The second element of the array will have the index 1. In this way, the fifth element of the array will have an index 4. So the first index 0 is normally called as a lower bound, and the higher index is being called as an upper bound. So these are the number of elements of the array. An array is normally used for collection of the data which are similar in nature. Say for example, we can have an array of integers, or we can have an array of real numbers, or we can have an array of characters. So the data element should be similar in nature, and whenever we have such collection, then that can be called as an array. As I said you that in real life, array is very useful to us, because suppose you have been asked to purchase some items from a shop. So normally what you do is that you prepare a list of items. So this list of items is just nothing but an array. Linked list is another linear data structure that is frequently used by the programmers. A linked list is also a list, but the difference is that between the linked list and array is that the array elements are stored sequentially one after the other in the memory. While in the linked list, you will find that we have a collection of nodes where the first value will represent the value of the node and the second value will represent the pointer to the next element. So in the linked list, as its name indicates, it is a basically list, but it is a linked list, means there is a linking of the elements, and this linking of the elements is in the form of a pointer. So first element pointer will point to the second element pointer will point to the third element. In this way, it will go on pointing the next element. You will find that the last element in the linked list is being called as a tail, and it will point to nothing. Nothing means its pointer value will be nil. So the first element will be assigned a pointer head. So head will always point to the first element and tail will always point to the last element. So whenever we have such formation of the list, where you will find that the linked list structure is very efficient, because we make an efficient access to the linked list structure when we compare it to the array, because everything is pointed. Also, we do not require the sequential memory locations. While storing the array, you need a sequential locations, but while storing the linked list, you do not require the sequential locations, as you can store the elements of the linked list anywhere in the memory. Another data structure that is very useful to the programmers is the tree data structure. You will find that tree is a data structure which will have a structure like a tree. It means that it is a logical structure. Actually, we cannot have a tree in computer, but we can have a tree in the form of logic itself. So where like a tree, we have some root, then we have the subtree, then we can have the connection between all the nodes of the trees. And you will find that finally we have the leaves of the trees. You will find that it will represent the hierarchical relationship. So whenever we have certain data elements where there is a hierarchical relationship. For example, when I think of study material, then study material can have the different classes. Say for example, textbooks can be the study material, reference books can be the study material, even journals can be the study material, magazines can be the study material. So we can classify the study material into different categories. So whenever we have such type of the hierarchical data, then we can represent it by better fashion in the form of a tree. Suppose we have a family history, and suppose we want to represent all the family history or the belongingness of the persons to the family, then we can form a family tree. So you will find that the tree data structure is very useful, because it can be used for the representation of the different data elements which represent the hierarchical relationship. Stack is another list where we can have the insertion and deletion from the one end only. Suppose you have been gone to the library, and we know that in library there is a large collection of books. So the books are kept one on the other. You will find that whenever you are keeping the books one on the other, then that is just nothing but a stack. So the same concept is being used in the programming while preparing the data structure stack. So it is like a cylinder. You will find that the lower end of the cylinder is closed and upper end of the cylinder is open. And therefore, whenever I want to insert some element into the stack, then I can perform a push operation and I can go on adding the elements into the stack. The first element that is being added into the stack will go out the bottom. The last element that is being added into the stack will remain on the top of the stack. And so whenever I want to remove the items, then always I want to remove the last that is being inserted. So because it is on the top of the stack. And that is the reason this stack is being called as the last in first out, or LIFO. You will find that this stack system is very useful for implementation of many real life applications. In computers also, you will find that whenever we write the algorithms for compilers, the stack memory concept is very useful, and with the help of stack memory, we can easily implement them. Queue is another data structure that is frequently used by the programmer. As I said you that whenever you go to the railway station to purchase a ticket, you will find that there is a large queue there. So in the queue, what happens? The addition will take place from one end and the deletion will take place from the other end. So normally deletion takes place from the front end and the addition will take place at the rear end. And therefore queue is a data structure where the insertion will take place at the rear end and the deletion will take place from the front end. And that is the reason this data structure is being called as a first in first out system, or FIFO system. You will find that this data structure is used in implementation the algorithms for the operating systems, because in operating systems there are many tasks given simultaneously to the system, and therefore when there is a queue form of the task, the operating system will execute the task as per the structure of the queue. That is, the deletion will take place from the front and the addition will take place at the rear end. Graph data structure. You know that nowadays we people are making the use of Google Map. Whenever we want to go from one place to another place, we always find the proper distance between the two places by using the Google Map. We also check the what is the proper route of going from one place to another place. You will find that the software programs like Google Map or other maps, or whenever you go on the social media, you will find that there are large number of people on the social media, and there is a kind of connectivity or relationship maintained between the users of the social media. So such programs can be easily implemented by using the graph. So graph is a pictorial representation of the elements, and every element will be associated with the link. As shown in this diagram, you will find that there is a node called 0, then 1, then 2, then 3, then 4, and you will find that there are certain edges connected. From 0 there is an edge connected to 1, from 0 there is an edge connected to 4. So there are connection between the different nodes. These nodes are being called as the vertices, and these connections are being called as the edges. So as I told you, whenever we deal with the social media networks, or whenever we deal with the Google Map like things, you will find that such programs can be easily organized the data in the form of a graph. So graph is very useful whenever you go for the programming of such applications. So thank you friends, hopefully you have understood what are the different data structures available with us and some kind of introduction of these different data structures. In our later sessions, we will discuss more about these data structures only. Thank you all for viewing the session.